Today we're going to break down one of the most important concepts in C++, the for loop, a simple structure that lets you repeat an action a specific number of times. If you understand this well, half of programming becomes 10 times easier. So, what is a for loop? A for loop allows you to run a block of code repeatedly while controlling where the loop starts, how long it runs, how it moves from one step to the next, and it's ideal when you know exactly how many times you want something to repeat. So, the basic structure of a for loop in C++ is an initialization, a condition, and an update. Let's break this down clearly. Let's start with our initialization. So here we can set this integer I, right? We can set this integer I, and let's set it to 0, right? Okay, let's set it to 0, right? This sets a starting point. Usually we start at 0, but you can start anywhere, depending on what you want done, right? Now let's move over to our condition. So now, what do we want to happen? Let's say we wanted this loop to run about, let's say, 4 or 5 times. Let's do I is less than 5. So the loop runs as long as this condition is true. Once it becomes false, the loop stops. And then we need an update. If I were to just do this, run this loop as is, this thing is just going to repeat infinitely because I is never going to be more than 5. It's going to remain less than 5 forever. So we need to update this. So what we can do is we can change the value of I, and let's make it uh, every time the loop executes, I would just increment by 1. This changes the variable each time the loop runs. Most commonly, we increase by 1, but you can decrease or skip numbers too if that's what you want to do, right? So now we have this loop here. So if we wanted this loop to run, we have this loop. Right now it's not doing anything, but every time uh, every time it goes through an iteration of I, right? Uh, we want to print on the screen. Let's say we want to print on the screen a loop iteration, which iteration it's at, right? Set this and let's do I and let's do end line, right? So what's gonna happen here? Uh, I starts at 0. Is I less than 5? Run the code inside two braces. Update I becomes 1. Repeat 2 to 4 times until I reaches 5. When I is 5, the conditions become false and the loop stops. That is exactly what happens here. So we can do Control Shift B. We can do main.exe, and that's what happens. I started at 0, went over to 1, 2, 3, 4, and then it became 5, and then the loop stopped running. At that point, the loop stopped. We can also make it, we can make I is less than and equal to 5. We can do the same thing again, Control Shift B, and we can do main.exe, and then we get to 5, right? It's that simple. Then we have a nested for loop. A nested for loop is simply a loop inside of another loop. What happens here? We enter our first for loop with I, right? I is going to remain the same. Then this for loop here is going to iterate through itself, right? So J is going to be 0, 1, 2. Then I changes until this loop is executed, this loop here. Then I increments because that for loop is done. Same thing happens again, right? It's not too complicated. If you mess around with it a bit, you'll understand it quickly. If you understand how for loops work, you'll understand how nested for loops work. What I said was I is gonna be the same, right? I is gonna be 0 for first iteration of J, right? For first iteration through the J for loop, uh, I is gonna be 0, and then I is gonna become 1, and then J is just gonna repeat itself again, and then I is gonna become 2, and then J is gonna repeat itself again, and then finally it's gonna be done. So it's not that complicated. Uh, if you understand, if you have a general understanding of how for loops actually work, uh, then you'll have a solid grasp of nested for loops. You just need to practice a bit with it, try and understand it a bit more. You know, it's not too complicated. So here is something that I do want to point out. The C++ language has inherited some things from the C language, uh, things that are both good and bad. Here we have an example of that. This loop has no initialization, no condition, and no update. If you compile this, it will still compile. It's not going to give you any error. It's going to compile as normal, right? So you want to avoid things like this unless you're writing a program that must run continuously. So when you write these kinds of for loops, like for a game loop or embedded system loop, uh, things like this you need to watch out for, because this is still going to compile and give you no errors. And the reason it was made like that is because what if you don't want to initialize something in a loop? What if you want to initialize something outside of a loop? Like here, I'm going to initialize x to 1, right? Let's say x is something related to a game, right? I have no idea what it can be. Let's just make it x game. And then I'm going to say, yeah, x game is less than 3, right? X game is less than 3, and then I do X game plus plus, right? So now I just want to show you that it's completely possible to initialize values that you're going to use in a for loop outside of a for loop, right? Um, let's do C out. You are dead, right? Let's do end line, right? And then now we can do Control Shift B. You see, no compilation error with no initialization inside of our for loop. We still get no compilation error. So that's why I had to point that out, because without your initialization condition or an update, that loop would just run infinitely. So now let's do main.exe. Exactly. And there we have it. That is proof that you can initialize values outside of your for loop and then use it for the for loop. Why are for loops important? For loops create predictable repetition, reduce code duplication, help handle arrays and data structures, and form the foundation of algorithms. Understanding them is essential before moving on to things like vectors, sorting algorithms, file processing, and more. If you understand everything we covered today, initialization, condition, and update, you already know how to use one of the most powerful tools in C++. Practice writing small loops and experiment with different starting points and step sizes,